Astrophysicists who captured an image of the Big Bang's afterglow, and confirmed the Standard Model of Cosmology, won a $3 million breakthrough prize on 3 December. The team behind NASA's Wilkinson Microwave Anisotropy Probe WMAP provided key evidence backing the theory that the cosmos is composed mainly of dark energy and dark matter, with a small serving of ordinary matter. It is a well-deserved award for an amazing experiment, says astrophysicist Andrew Yaffer at Imperial College London, who is a member of the team behind the rival European Space Agency's Planck satellite. The WMAP experiment is the one that made our current cosmological paradigm almost impossible to get out of. The prizes, which total $22 million, were announced at a glamorous ceremony hosted by actor Morgan Freeman at the NASA Ames Research Center in Moffett Field, California. Other prizes were awarded for work in the life sciences and mathematics. The initiative was set up 6 years ago by Google founder Sergey Brin, internet entrepreneur Yuri Milner, artist Julia Milner, Facebook founder Mark Zuckerberg, pediatrician and philanthropist Priscilla Chan, and Anne Wojcicki, founder of genomics company 23andMe. Previous laureates judged the entries. The WMAP team won the Fundamental Physics Prize for mapping subtle temperature differences in the cosmic microwave background radiation that permeated the universe about 380,000 years after the Big Bang. Chuck Bennett at Johns Hopkins University in Baltimore, Maryland, who is one of the WMAP's 5 team leaders, says that he is particularly grateful that the prize was able to recognize all 27 members of the WMAP team, unlike the Nobel Prizes, which may not be shared by more than 3 people. Everybody played a significant role in the experiment's success, says Bennett. The probe helped to pin down the age of the universe to 13.8 billion years and detailed how it is made up of just under 5% ordinary matter, around 25% dark matter and roughly 70% dark energy, which pushes it to expand at an accelerated rate. Together, these parameters confirm the current paradigm set out by the Standard Model of Cosmology. But intriguingly, more recent data from the Planck satellite give slightly different results. The discrepancies are real and serious, notes Yaffer. The most likely explanation, he says, is that there are systematic errors in one or both experiments, or differences in their data analyses that have so far been overlooked. But if they hold up, the anomalies may signal a deviation from the Standard Model. Influential work. Joanne Corey, a plant geneticist at the Salk Institute for Biological Studies in La Jolla, California, won one of 5 $3 million Life Sciences awards. I was amazed, because most awards go to biomedical areas, says Corey, who identified the genetic signaling mechanism for photosynthesis by studying how mutant varieties of the Arabidopsis thaliana mustard plant react to different light conditions. Corey hopes that the prize will raise awareness of her initiative to tackle climate change by crossbreeding plants to engineer varieties that can pull 20 times more carbon dioxide from the atmosphere than normal ones can, and store it deep underground. The other life sciences winners were Don Cleveland at the University of California, San Diego, who developed experimental gene-silencing therapies and DNA drugs to treat diseases of the brain and nervous system, Kim Naismith at the University of Oxford, UK, who discovered how DNA packs into cells without getting tangled up, and Peter Walter at the University of California, San Francisco, and Kazutoshi Mori at Kyoto University, Japan, who both worked on elucidating the quality control system in cells that detects unfolded proteins that have the potential to cause disease. Mathematicians James McKernan, at the University of California, San Diego, and Christopher Haken, at the University of Utah in Salt Lake City, shared the $3 million mathematics prize for work in algebraic geometry, which expresses the solutions of certain equations as higher dimensional geometric shapes. They were recognized for contributions to the Minimal Model program, which aims to find the simplest geometric solutions. 6 awards of $100,000 each were also made to early career scientists, along with a Junior Breakthrough Prize for the Best Original Science and Mathematics Video made by a teenager. This article is reproduced with permission and was first published on December 4, 2017.